Hello everybody and welcome. In today's video we are covering proofs of parallelograms. So before we dive into proofs, let's talk about exactly what a parallelogram is, because if we're proving something to be a parallelogram, we first of course need to know what that is. So as a reminder, a parallelogram is simply a quadrilateral such that the opposing sides are parallel with one another. And some attributes of a parallelogram is that the opposite angles are congruent with one another. So these pink angles are congruent and these blue angles are congruent. Another feature is that the adjacent angles will be supplementary, meaning this pink and blue angle will sum to 180, and of course this pink and blue angle will also sum to 180. A couple other features of parallelograms is that all, or not all sides, but the opposite sides of parallelograms are congruent with one another. So the top and bottom are congruent with one another, and the left and right sides are congruent with one another. Another feature of parallelograms is that the diagonals will bisect one another, such that this part in green will be equivalent to this part I'm marking in green, and this part that I'm marking in purple will be equivalent to this part, which I am marking in purple. So there are all the properties of a parallelogram, and with that we can talk about the 6 features where if we identify them while we're proving our shape to be a parallelogram, we can say that yes, this shape is a parallelogram by the definition of parallelogram. So firstly, if one pair of opposite sides are both parallel and congruent, then we can say that the shape is a parallelogram. If the diagonals bisect each other, we can also say that our shape is a parallelogram. So I'm going to say if D1 and D2 bisect, this is a way for us to determine that our shape is a parallelogram. Number 3, if both pairs of opposite sides are parallel, so if both opposite sides are parallel, this is a way to determine that you have a parallelogram. A fourth way to determine is if both pairs of opposite sides are congruent. So here we'll kind of shift this into, so if both pairs of opposite sides are parallel or congruent, this is a way to determine that your shape is a parallelogram. Next, if both pairs of opposite angles are congruent, so if both pairs of opposite angles are congruent, then you can determine that your shape's a parallelogram. And then lastly, if one angle is supplementary with both of its adjacent angles, then your shape is a parallelogram. So we'll say if an angle is supplementary with both of its adjacent angles. All right, so if you run into any of these 5 features, then you can determine that your shape is a parallelogram. So with that, let's get to the proofs. Number 1, given SC is perpendicular to TV and DG is perpendicular to TV, SC is congruent to DG and SV is congruent to TD, prove that this is a parallelogram. Man, I sure get tongue-tied saying all that. But to start any proof, of course, we have our statement and reason columns, statement and reason. And the first step is to restate your given. So we're going to say if SC is perpendicular to TV and DG is perpendicular to TV, and then of course the rest of our given, SC congruent to DG and SV congruent to TD. And this is our given. Okay, so we have our statement and our reason columns. After you restate your given, you ask yourself, what is the repercussion of my given? Firstly, we were given that SC is perpendicular to TV, and that tells us that these angles are right angles. We are also given that DG is perpendicular to TV, so these angles will also be perpendicular. So just to save space in the statements, I'm going to call all these angles 1, 2, 3, and 4. And I will say in my statement that angle 1, angle 2, angle 3, and angle 4 are right angles. And this is, of course, by the definition of perpendicular. All right, what was the other given statement? It was that SC is congruent to DG. So let's mark that. These two lines are congruent. And we're also told that SV is congruent to TD. So this bottom portion is congruent to this top portion. So I'm going to call this top triangle T for top and this bottom triangle B for bottom. And I want you to notice that using the side-side angle postulate, we can say that triangle T is congruent to triangle B. So we'll say triangle T is congruent to triangle B by the, again, side. Oh, we can't use side-side angle, can we? This is one of the ones you can't use. So what can we use? We can't use side-side angle. Oh, wait! We can use it in this case because it's a right angle, and so it's not by side-side angle, it's by the hypotenuse leg postulate. We can say that these triangles are congruent because our hypotenuse and one of our legs are congruent in this right triangle, therefore these triangles are congruent. With that, we can say that this angle here and this angle here are congruent by corresponding parts of corresponding triangles are congruent. Here I'll go ahead and call this angle 5 and angle 6. Again, just to save space in my statement and reasoning columns. So we're going to say angle 5 is congruent to angle 6, and that's because corresponding parts of corresponding triangles are congruent. And with this, we can say that line TD, our bottom line, and line SV, our top line, we can say that they're parallel by the converse of our alternate interior angle theorem. So here, let's scroll down just a tiny bit and say that TD is parallel to SV by the converse of alternate interior angle theorem. And now look at what we have. We have a pair of sides of our figure, of our quadrilateral, that are both congruent and parallel. Therefore, by definition of a parallelogram, T TDVS, shape TDVS is a parallelogram by definition of a parallelogram. Excellent, excellent. So TDVS is a parallelogram by definition of a parallelogram. Excellent. So that was our first proof. Let's continue forward to this next one. Again, we have our statement. Let's write down our statement and reason columns. Our first statement is always to restate the given. So we're going to say D is a midpoint of AB. DF and BC bisect. DF bisects BC. And we want to prove that ACFD is a parallelogram. So we have our statement and reason columns for our proof. Again, the first step is always to restate the given, and the second step is to ask yourself, what's the repercussions of my given? Here, we're told that D is a midpoint of AB, and if D is the midpoint, then that implies that AD is congruent to BD by definition of midpoint. Let's mark that. And then what else were we given? We were given that DF bisects BC. Okay, if these bisect one another, we're told that they bisect one another, so this goes forwards and backwards. So we know that DE is congruent to EF, and we know that BE is congruent to EC. And this is by the definition of a segment bisector. And let's mark this on our picture so we can see exactly what's happening. We know that this side is to this side, and we know this side is to this side. Okay. What else? Now, after you say the repercussions of your given, you want to ask yourself, does my picture give me any more information? And it does give us a little bit of more information. We can see that this angle and this angle are vertical angles. I'm going to call them angle 1 and angle 2, just so I don't have to say angle BED and FEC and clutter up my space. I'm just going to call them angle 1 and angle 2. And we'll say that angle 1 is congruent to angle 2 by the vertical angle theorem. And now that we have that marked, we can see that, hey, triangle DBE and triangle CEF, they are congruent to one another by the side angle side postulate. So let's state that. So we can say triangle DBE is congruent to triangle, and it's going to be triangle FCE. Make sure you write it in the proper order. These triangles are congruent, and they're congruent by the side angle side postulate. Okay, let's scroll down a little bit more. Give us some room. Here, let me shift my figure down so that we don't lose it. We still see exactly what's happening. Okay. So we have just proved that our triangles are congruent. And what extra info can we gather from the fact that these two triangles are congruent? Well, since the triangles are congruent, we can say that, what can we say? We can say that FC is congruent to DB by corresponding parts of corresponding triangles. So we'll say that. So we'll say FC is congruent to DB by corresponding parts of corresponding triangles are congruent. And then we can say, well, we can say that AD is congruent to FC. We'll say AD is congruent to FC, and this is by the transitive property. And we know this because it was given to us that D is a midpoint, so we discovered that AD and DB are congruent, and since DB is congruent to FC, then that implies that FC is congruent to AD by the transitive property. So we have that these sides are congruent to one another. What else can we determine? Well, we can determine that this angle here is congruent to this angle here. Again, I'll call these angles angle 3 and angle 4. So I will say, in here, let's scroll down even more. Let's scroll down even more. Let me again lasso my shape so we have everything in one place. Scroll it down so y'all can see. Okay. So we know that angle 3 is congruent to angle 4. Again, by corresponding parts of corresponding triangles are congruent. And then what's the repercussion of this? Well, this implies that FC and AD are parallel. This implies that FC is parallel to AD because this is the converse of the alternate interior angle theorem. Just like last time, this is the converse of your alternate interior angle theorem. And with that, we have that one pair of opposite sides are not only congruent, but parallel. Therefore, we can say that our shape, here, let me draw a parallelogram. Our shape ADFC is a parallelogram by the definition of parallelogram. Excellent. That was proof 2. Let's go on to our last proof for this video. Let's check it out. Again, we need our statement. We need our statement and reason column. Our first statement is always to restate the given. So that's angle D is congruent to angle 1, and angle 1 is congruent to angle E. And we have CD is congruent to HM. Then, of course, we have our reason column. The first reason is, of course, the given. So we know that angle D is to 1, which is also to E. And that was all in the given. What's the repercussion of these three angles being equivalent? Well, maybe not so much angle D, but angle 1 and angle E being equivalent tells us what? Well, it tells us that this triangle is isosceles. Therefore, HM is congruent to HE by the converse of your isosceles triangle theorem. So we know that HM is congruent to HE by converse of isosceles triangle theorem. What else were we told in our given? We were told that CD is to HM. So we know that CD and HM are equivalent. So that tells us what? Well, that means by the transitive property, CE would be to HE, but that's not as relevant for us having a parallelogram. So let's see what we have next here. Okay, we have these sides congruent. DE. You know what I imagine? I imagine this given, I accidentally made this problem too easy for us all. In the given, I typed HM. I meant to make it HE so that it would be a little bit harder. But we are actually already told that CD and HM are congruent with one another. And since D and angle 1 are congruent with one another, then by the converse of corresponding angles theorem, CD and HM are parallel. So CD is parallel to HM by the converse of corresponding angles. And then again, since we have a pair of opposing sides which are both congruent and parallel, we can say that our figure is a parallelogram. So we know that CHMD is a parallelogram by the definition of parallelogram. So to recap this proof, I made a tiny bit of a mistake. I made it a little bit too easy of a problem. If I had done it correctly or written it the harder version such that CD was congruent to HE, then we would have used the converse of the isosceles triangle theorem to determine that all three of these sides are congruent. Then we would have used the transitive property to say that CD is congruent to HM. In this case, it was a little bit simpler in that CD was already given to us to be congruent to HM, and the fact that D and 1 was also given to us to be congruent, we could just erase this middle step where we use the converse of the isosceles triangle theorem. We can erase that, and we can immediately just say, by the converse of corresponding angles theorem, CD is parallel to HM, therefore our shape is a parallelogram. So there was 3 proofs. I hope you found this video helpful. If you did, hit that subscribe button. Let me know down in the comments below, and I will see you in the next video.